everyone. In today's video, we will know about AWS X-Ray. So how it works. So AWS X-Ray is basically it helps to analyze and debug the production distribution, and also it helps developers to analyze and debug applications. So let's see the agenda. So in this video, we will learn what is AWS X-Ray, why we need AWS X-Ray, benefits and the architecture, key features, how AWS X-Ray works. So lastly, we will see demo also, how it traces and how it works. So let's move to what is AWS X-Ray. AWS X-Ray is a service, it's a fully managed service that helps analyze and debug the applications. So it basically helps to analyze and debug the application with the help of the AWS X-Ray, and it's a fully managed services. And also it helps developers to analyze and debug the production distributed application, those built using a microservice architecture like it. So AWS X-Ray mainly helps the developers to to analyze and debug the application. So some of the errors or issues occur. So that's the time it helps to developers to analyze and debug those applications. And also it's using the microservices architecture, and it provides an end-to-end view of requests as they travel through your application and shows a map of your application underlying the components. The X-Ray it also provides an end-to-end view of requests. So from the starting point to end of the request, it shows the end-to-end view. What are the phases like if they travel to your application, and how it shows the map of your application and what are the underlying components. So those are all showing in the AWS X-Ray. So it's basically like that. It's one of the fully managed services. It helps developers to analyze and debug their applications, and also it's using the using microservices or architecture. It traces all your requests from end to end. What are the phases it's travel to your applications, and it shows the map of your application also. So it's showing in two ways. One is through your applications to end to end, and also shows a map of your application underlying components. So this is all about what is AWS X-Ray. So let's move and see why we need. Why we need AWS X-Ray? Because it's a services that collects data about the requests that your application serves, and it provides tools that you can use to view, filter and gain insights into that data to identify the issues and opportunities for optimization. Why we important? Because it collects all the data about the requests that your applications in the what is your application, what is AWS X-Ray I will told, right? So it provide end-to-end view of requests that travel to your application. So like that, it collects the data about the request that your application serves, and it provides some tools that we can use to view the application, and with the help of the tool we can view, filter and gain insight into the data, and also it helps to identify the issues and opportunities for the optimization. So that's why we need the X-Ray. And also it aggregates the data into traces, which shows the path of the request through your application. With the help of the X-Ray, it can data into traces, it can traces the data of your application. It shows the path of the request through your application. And also without the X-Ray, troubleshooting performance issues, errors or bottlenecks become challenging, as traditional logging and monitoring methods may not provide enough context or details. So with the help of we can do all this, right? So without X-Ray, what are the causes we occur, right? So it's troubleshooting the performance issues. So occur the errors or bottlenecks becoming challenging, and also it causes the traditional logging and monitoring methods may not provide the context or much details. So that's why we need the AWS X-Ray. So this is about why we need the AWS X-Ray. So let's move to the benefits of AWS X-Ray. So the main benefits are it's identify the performance bottlenecks, detect latency, distributed tracing, root cause analysis, error detection, visualization and analytics, security and compliance. So why we need means without X-Ray, it occurs the monitoring methods may not provide and bottlenecks become challenging, right? So in the benefits, we see the first point is it's identify the performance bottlenecks. So in this benefit, it helps to find the issues like slowdowns, timeout, or any edge case errors. It can be identified, and it helps to track the performance of your application and services, including detailed latency informations. So it allows you to monitor how long requests take to process and where bottlenecks might occur. So it helps to identify the track the performance of your applications. So and find the issues like slowdowns, timeouts, and edge case errors. The next is detect latency. So visually identified latency distribution between nodes and edges. So any identity, it's visual identify the latency, and the between distribution between nodes and edges, what the distributions between it can be identified. So the next is distributed tracing. So AWS X-Ray enables distributed tracing, which means it traces the request as they travel to various microservices or resources in your application. This helps identify which part of the system is experiencing the issues or delay. So distributed tracing, it helps to identify the which part of the system it can experience issues or any delays can be identified easily with these benefits, and also it traces the request. It travel to various microservices and resources. The next is root cause analysis. With the X-ray trace visualization, you can pinpoint the source of errors or performance issues. It shows the flow of requests and interaction between the services, making it easier to trace the root cause. So, root cause analysis means without X-ray trace visualization, it's the source of error or performance issues can be shows the flow of the requesters and interaction between the what are the interaction between services, and the flow of the request can be so shows in this error. So it making it easier. So when we use the root cause analysis, it's making it easier to trace the root causes. The next is error detection. X-ray helps to detect the anomalies such as failed requests or high error rates. You can also monitor the exceptions and get details insight into the errors, such as specific services involved. So using the AWS X-ray, one of the benefit is error detection. Like so when such as mainly failed requests and high error acquired, so you can easily monitor the exception and get detailed insights about the errors, so such as the specific services involved. The next is visualization and analytics. And visualization and analytics. So X-ray provides a visual interface to explore the trace data with service map. So with the help of the service map, it provides a visual interface to explore the data, and also latency graph and detailed request logs. It helps developers to quickly understand the system's health and pinpoint where the things might be going wrong. So X-ray helps to visualizing and analytics the data, and developers can quickly identify it and understand what are the system's health and where the things might be gone wrong. It can be easily identified, visualized with the help of the X-ray. The next is security and compliance. AWS X-Ray provide a robust security features such as data encryption and the ability to control the access using the AWS identity and access management, ensuring you trace the data in secure. So we are using the IAM role to trace our data. So while we using the IAM, right, so that why it provide a robust security feature. So it can while we tracing the data, it will be safe. Oh, that's why we say that AWS X-Ray provides the robust security features. So this is about the benefits of AWS X-Ray. So the next is architecture of AWS X-Ray. So architecture means how it works and what are the steps involved in the AWS X-Ray. So first it's AWS X-Ray, then it collect the traces and record those traces and view the service map and analyze the issues. So let's see one by one. AWS X-Ray. So AWS X-Ray, we know that already. So it helps you to analyze and debug the application built using the microservices and serverless architecture and quantity customer impact. So it collect the traces. So collect the data about the request from each of the underlying applications, services it passes through. So in the AWS X-Ray, first it helps the developers or any customers impact, that helps to analyze and application and debug the modern applications with the using of any microservices or serverless architecture. So while coming to collect the traces, so it collect data about the request from each of the application services it passes through. So what are the application it passes through? So step by step, like end to end. So it collect the data about the requests from each of the applications. The next is it record the traces. So X-Ray combines the data gathered from each services into singular unit called traces. So while it collecting the data from each of the underlying application services it passes through, right? So it combines the data together from each services into the singular unit. So that's it called as the traces. Then view the service map. So it view the service map to see the trace data such as latencies, HTTP status and metadata for each services. So once it collect the traces, then we can view that services map. So in the demo session, we will see how we can collect the traces and view the service map. So in the service map, we can see the trace data such as latency, HTTP statuses and metadata for each the services. The next is analyze the issues. So drill into the services showing unusual behavior to identify the root issues. So what are the issues and error can be occurred while it may be delay. So it can be easily analyze the issues through the services. Those it showing the unusual behavior or any identified to root issues, we can easily analyze where the system gone wrong. So this is about the architecture of AWS X-Ray. So let's move to key features of the AWS X-Ray. So the key features are end-to-end tracing, service maps, latency detection, annotations and metadata integration, role-based access control, error and fault detection. So let's see one by one. End-to-end tracing. So basically key feature means AWS X-Ray tool that helps you to monitor and troubleshoot the applications by tracing the request across the services. So let's see one by one, that is end-to-end tracing. So it collects data from the services and shows how requests move through them. So end-to-end tracing means it collects the data from the service, each services, and also it shows how the requests move. The next is service maps. So it shows how services are connected in an application's architecture. The next is latency detection. So latency detection shows where the latency occurs in the services. So sometimes issues occurs or it may be delayed. So it shows the where latency occurs in the services. The next is annotations and metadata. So it adds the custom information like user IDs and error codes to traces. So in the annotations and metadata, it add all the customer information like users IDs and where the error occurred to, like error codes to traces the data. The next is integration. Works with many AWS compute options including EC2, ECS, EKS and Lambda. Like AWS is integrated with many other AWS services, like they are EC2 instances, ECS, like Elastic Container Services, Elastic Kubernetes Services and Lambda functions like that. It can be integrated with many AWS services. The next is role-based access control. It control who can access the traces and how. So it can easily, we can identify the controls who can access the traces and how can they access. The next is error and fault detection. So X-Ray helps detect the errors and faults in your applications by showing traces where failures or exceptions occur. It highlights the services or operations responsible for the failure, it making it easier to troubleshoot. So where error means we can showing the while tracing the application from end to end, it shows where the failures or exception occur. It can be highlighted the services or operation that is responsible for failure. So it's easier to troubleshoot. So this is all about the key features of the AWS X-Ray. So let's move and see how AWS X-Ray work. What are the steps it going through? So first, it's instrumenting your applications and request tracing, service interaction tracking, and sending the data to X-Ray daemon, and the processing trace data, visualizing the data in the X-Ray console, and alerts and monitoring. These are the steps it works in the AWS X-Ray. So let's see one by one. Instrumenting your application. So in the instrumenting, AWS X-Ray works by collecting trace data from your applications and visualizing it to provide insights into the performance and behavior of your applications. So instrumenting your application can be instrumenting your application by the two ways, that is adding the X-Ray software development kit or automatic the instrumentation. So in the adding X-Ray SDK, it uses the AWS X-Ray to need to instrument your application code. That involves adding the X-Ray SDK to your application in the programming languages you are using, like so it can be add the SDK in our application to in the programming languages that we are using, like Java, Node.js, Python, like that. It can be add the X-Ray SDK to the application. The next is automatic instrumentation. So AWS also offer automatic instrumentation for certain AWS services. So in the features I've already told that, right? So it integrated with other AWS services, like that. It can for automatic instrumentation for the certain services like AWS Lambda API Gateway or Elastic Bunch Stack, so which reduces the manual setup needed. So some of the services need manual setup, so while it integrated with other services like Lambda API Gateway, Elastic Bunch Stack, it can stop the needed the manual setup. So that is instrumenting your application. The next is request tracing. So request tracing can be in the trace creation, segments and subsegments. So the trace creation, when request comes into your system, the X-Ray SDK generates a unique trace ID that is associated with the request. The trace ID is passed along to request flows through your services. So in the trace creation, so when the request comes into your system, so when in the instrumenting adding X-Ray and automatic instrumentation, right? So it comes into the when request comes into tracing your system, so the X-Ray generates a unique ID that is associated with the request. It generates unique ID. With that ID, the request flows through your services. The next is segment. So each service or resources that is processed the request creates a segment. A segment represents a unit of work and contains the metadata, such as how long it takes, processes, errors or other relevant information can be contained in the segments. The next is subsegment. So with the segment, subsegment can be created that represent smaller unit of work, like it in the individual database query or external HTTP requests that are the service mix. So within the segment, we can create it the represent of the smaller unit of work can be called as subsegment. So it can be database query or external HTTP request or service maker are called as the subsegments. The next is service interaction tracking. So service interaction tracking can be the service as the request travel through your application, like various microservices or database, etc. So each service record the additional information about its processing of the request, like including performance, matrix, error or any interaction with other AWS services. It can be travel to your applications. So in the service map, AWS X-Ray collects all the traces of your application and builds a service map, which helps to visually show the relationship and dependency between the different services and resources that handles the request. So the next is sending data to X-Ray daemon. So the X-Ray SDK or agents running in your application or AWS infrastructure send the trace data. So in the X-Ray daemon, it runs on your application instance, like example EC2 instance or Lambda function. It forwards the traces data. It receives the AWS X-Ray services. So while sending data to SDK or any agents running in your application, in the X-Ray daemon runs the application instances and it forward to traces the data to receive the service. So after sending the X-Ray daemon, it processing the trace data, So the X-ray service collect the data from the daemon and processes it. So the data is stored and indexed for querying and visualization. So the trace aggregation means the service aggregates the trace data to generate a ununified view of the request flow across the services, and also it enables it to group similar traces. So while sending, it receives the data from the daemon and it processes the traces. The next is visualization data in the X-ray console. So it's a service map, detailed tracer analytics can be visualized in the X-ray console. So in the service map helps to process the trace data to display in the AWS X-ray console as a service map. So it shows the flow of requests across services with performance matrices like response time, error rates, or latency visualized in real time. Can be shown visualized in the service map. So detailed trace can click or individual traces in the service map to drill into the details of each trace. It shows your sequence of operations and allows you to analyze the performing issues like error, failures, or any database queries like can be detailedly traced in the individual traces of your map. The next is analytics. So analytics allows the X-ray allows you to search and filter the traces based on various criteria such as error rates, latencies, and request path. So this helps you to identify the patterns and optimizing the performance. So in the visualization can be occurred in three ways. One is service map, detailed traces, and analytics. In the service map, it helps to shows the flow of request services and performance. In the detailed trace, in the detailed trace, it can shows the operations and analyze you to performance the issues. In the analytics, it helps to various criteria such as filter, rates, latency, and request path. So the next is alerts and monitoring. So alerts and monitoring, the AWS X-Ray integrated with the Amazon CloudWatch to provide the real-time monitoring and alerting the abilities. You can set up alarms for high error rates or latency issues or other custom metrics. So the AWS X-Ray it integrated with the Amazon CloudWatch, so it helps to monitoring and alerting the abilities. While we can set up the alarms for high error rates or any issues or other custom metrics. And also the X-ray traces are also integrated with the AWS Cloud Trial also. So in the Cloud Trial, you can correlate your application level tracing data with other AWS events and logs. So in the CloudWatch, we can set the alarm for high rate errors or latency issues. So in Cloud Trial, we can correlate your application level and tracing the data with the other AWS events and logs. So this is how AWS works, X-ray works. So let's move to demo and see how the things go on and how the X-ray tracing the data and it shows the map we can easily trace. So let's move to the AWS console and see the practical thing. Let's see the demo of the AWS X-Ray. So here search for X-Ray. So here the X-ray can be practically in two ways. One is AWS X-Ray, the another one is CloudWatch X-Ray. So just can go with the CloudWatch. So here we can see in the CloudWatch there is a X-ray traces. So here also we can do the X-ray AWS X-Ray demo. So here I am doing in the CloudWatch resources only. So here go to the traces. So here we can see the traces, it capture all the traces span. So go to traces, the table shows traces with the updates. So here we not created any tables to traces with the updated. So what we need to do is we set up the demo app. So to do the trace, first we need to set up the demo. So let's go and set up the demo. So set up demo app. So for the setup the demo app, we need to create the sample application with the CloudFormation. To launch the sample application using the language is Java. So to create the sample application with the CloudForm, So it's a pre-filled template in the CloudFormation console to create the stack and launch your sample application. We provide the steps to how to create sample application. So we provide the steps. So choose the launch sample application, then choose next, and optionally edit the stack name, choose the next. So add the tags and sample stack and confirm the IAM resources. So let's go and create the sample application with the CloudFormation. So we need to create the stack, right? So to creating the stack in the CloudFormation, it provides a prerequisite, the prepared template. So you can also create a template by scanning your existing resources. So you can prepare template by two ways. One is choose an existing template and another one is build from the infrastructure composer. So here I am choosing the existing template, and also it specify the template. So it can sample CloudFormation template that can help you to get the started on new infrastructure. So here I am using the template sources, the Amazon S3 URL. So it provide the URL. So click on next. So the second step is specify the stack detail. It provide the stack name. So you can change the stack name also. You can let it be the default. And also here we can see it provide the maximum size. So here I am using the one. You can use up to whatever you want. So for the demo purpose, I'm only using the one parameter, and it provide the public backend image URI, data volume, root volume, and the ECS cluster name endpoint, EC2 instances, and the email, subnets IDs, VPC CIDR, everything it can be provided in the stack detail. So click on next. So the next is configure the stack option. So we can be configure the stack option. We can provide the tags. So it's optional. If you want, we can provide the tags. Otherwise, let it be. The next is permission. So permission is a IAM role permission. So it's also optional. If you want, you can choose or select the any IAM you want created. So otherwise, you can let it be. So here I'm not giving any IAM role because it's optional, right? So the next is stack failure option. It's a behavior and provisioning failure. That's a rollback all the stack resources and preserve successfully provisioned resources. So here I'm choosing the rollback all stack resources. So the next is delete newly created resources during a rollback. So it can asking for you the two ways to delete the resources during the rollback. One is say use the deletion policy, and the another one is delete only newly created resources. So here I am using delete all newly created resources. So select this one, and these all the advanced options. So this stack policy, rollback configuration, notification options. So if you want, you can go and edit this one. These are all optional. If you want, you can do it. Otherwise, let it be. And you can select this to acknowledge the AWS CloudFormation. It creates the IAM resources with the custom name. So next, click on the next. So the last step is this create stack and specify the stack detail and configure stack option is done, right? So the fourth step is review and create the steps what you are all done. So template, specify all the stack details and configure the stack options. So just click on submit. So here we can see the name X-Ray sample, right? The stack we are giving, it's in the create in the progress. So here we can see the event updates, go to resources. So here we can see, so it created the IAM role, DynamoDB, SNS, VPC. So it's created all the resources along with the stack. So let's go and check it's associated with the other resources or not. So firstly, I will open all the resources, that is VPC, EC2 instance, Lambda function, and load balancer, DynamoDB, for route tables also. So once it's created the load balancer, it will create the route table also. We will let go and check. So it's still in create in the progress. Okay, so just go to VPC and check. So VPC, go to your VPCs. Yeah, so here we can see the X-ray sample. So it's created the VPC. So just go to instances, go to your instance. So instance is not yet created. So go to lambda function. Go to functions. So lambda function is also not yet created. Go to load. Yeah, so here we can see the load balancer is created. So it's in the state of provisioning. So go to dash DynamoDB, go to tables. Here we can see the table is also created, and check for route tables, right? So route tables, it's to sub yeah, the X-ray sample, the route table is also created. So just go to the cloud formation, refresh this. So it's still in the create in progress stage, so we will wait it up to it complete the creation. So just go to load balancer. Okay, instance lambda function, refresh this. Yeah, so the lambda function is created, and go to instance. Yeah, so here we can see the instances is created. It's in the state of running state, right? So go to the lambda function, go inside this. So here we can see it's create the lambda function with the diagram template, right? So it's created the lambda function. The next thing what we need to do is just go for the load balancer and refresh this once again. See. So the load balancer, it's in the active state. Just go and check all the creation is completed or not. So we want to wait, it's still in the creating progress. So it's created the ECS services, it's in progress now. Yeah. So the creation of the stack is completed now. Just go to the load balancer, copy this DNS name, and go to the Chrome, paste it here. So the site cannot be reached, right? Just reload this. So here we can see. So it's the DNS is running in the, it's created the username session. So whatever we want to create in the stack, it's created. It's using the powered by AWS EC2 launch instance type via the ECS. So Elastic Container Service, with the help of Elastic Container Service, is created the EC2 instance. So it contains the username, sessions, it's going to name it. So just go and traces in the CloudWatch. So just go to CloudWatch, go to traces. So here we can see 4.6 seconds ago the traces has been created. So it started the tracing, right? So what for that thing next we need to do is just go to here, just the username. So just click on create the game. So the game is created, right? Create a game, game name, giving as a game, holistic dog toy. So just click on create. So it's created, right? Just go to the traces. Yeah, so here we can see just 27 ago, so it starting the traces. So just go inside this. So here we can see it contain all the details of the tracing details. So the client is associated with the ECS container with the front end, and also it's with the session, the expired session of the DynamoDB table. So it's established the connection there, right? So just go back here and go to the here. So just play the game. So here we can see started the game, right? Okay, then go back here, just refresh this trace. So the recent trace details. So here we can see the client is associated with the established with the connection of ECS container front end. Let's go with the DynamoDB table, right? So it contains all the details of DynamoDB, the ECS container, the time taken. So it contains every trace details. So every time when we click on the next step, so it tries the details. So just go here and play the game. Here we can see, so X wins, right? So it's again it traces. So for the confirmation, just go here, just refresh this trace. So here we can see that 20 seconds ago it can be traced again. So it contains the client is established the connection with ECS container, and the score keep is state the DynamoDB table. So when it's in the state of the DynamoDB, it's completed, it shows the state. So it traces all the details and end-to-end steps by each AWS X-Ray. So it's contained the end-to-end details. So this is how we need to traces the application. So with the help of the AWS X-Ray. So and also here we can see there is a trace map, right? So click on the trace map. So here also it contains all the details. So I will show you. Wait. Go to trace map. So here we can see the first is client is established with the connection of ECS container. Then it goes to the wait. So here it goes to the establish the connection with the ECS container and the game, and it moves to the DynamoDB table. In the play game we have started moving, right? So it shows that in the database tables it's moving. The next is send the notification, the session is expired, and here we can see it's the score keep as running in the state, and it's the user DynamoDB table. So the client is started the running in the game. So when we start running in the game till it will end the game, it traces all the details of the game. So it contain in the trace map, it contain all the details of the map. In the traces, it contain each and every step of the trace details. So this is how we need to traces the details using the AWS X-Ray. So after this, how we need to delete this? We don't need to delete everything. like we don't need to delete VPC instance X-Ray. So everything we don't need to delete. Just go to the cloud formation. So in the stack, just click on the delete. So click the delete. So it's delete in progress. So it deleted all the resources associated with. So just go for the VPC, refresh this. So it take few more minutes. Here we can see the EC2 instance is shutting down. Go to the Lambda function. So here we can see the Lambda function is also deleted. Load balancer is deleted. So dynamo times. So deleted the route tables. So just go to VPC and refresh this. So it takes few more minutes. So load balancer deleted, right? And DynamoDB tables. Yeah, here we can see the DynamoDB tables also deleted. Route tables is deleted. Lambda function also deleted. So instances refresh. Yeah, instance also terminated. Just go to VPC and refresh this. So VPC is also deleted. So just go to cloud formation and refresh this. So it deleted all the resources associated with the cloud formation, the CloudWatch X-Ray. So this is all about the AWS X-Ray, how it traces all the details from end to end, and it views the API gateways and load balancers, VPC, and how we can trace and how the trace map can work. So this is all about AWS X-Ray. Thank you.